Hello everyone, very good evening to all of you. Good evening, good evening, good evening. So, video and audio both are fine. Shall we proceed? Please let me know. Video and audio both are clear. Shall we start today's session? Okay, so in last session, in last class, we discussed about the capillarity, right? In last class, we discussed about the capillarity concept, and we calculated capillary rise or capillary fall in case of the tube, right? If there is a narrow tube of diameter small d, then what is the capillary rise or capillary fall? Similarly, we calculated for the plate, right? And similarly, we calculated for a concentric tubes, right? Concentric tubes having annular space, right? So I think. Okay, now it is okay. Now it is okay. Now voice is clear now. Now fine. Okay. So previous question is clear or not? This question is clear or not? This question is clear or not? Angle of contact of a drop of a liquid is acute. Theta is less than 90 degree. So if theta is less than 90 degree, then that liquid drop is spread like this, right? And theta is less than 90 degree. This is possible when adhesion force is more as compared to the cohesion force. Adhesion force is more as compared to cohesion force. Now come to the next question. Question number 2. MCQ problem. Question number 2. Question number 2. What is the capillary rise in a narrow two-dimensional slit of width W? Half of that in capillary tube of diameter W, 2/3 of that in capillary tube of diameter W, 1/3 of that in capillary tube of diameter W, 1/4 of that in capillary tube of diameter W. So this is a question. So beta, we already discussed about the capillary rise or capillary fall in case of a narrow tube. So let us consider a narrow tube of diameter W, of diameter W. So what is the capillary rise in this case or capillary fall? What is the capillary rise or capillary fall in this case? So this is the 4 sigma cos theta divided by gamma multiplied by W. Gamma multiplied by W, where W is the diameter of the tube. Right. So this is regarding the narrow tube of diameter W. Now, instead of the narrow tube, if I consider two slit means better 2 plate, right? 2 plate, and in between these 2 plates that gap is W, right? In question it is mentioned na, 2-dimensional slit of width W, right? That is nothing but the plates of gap W, right? Plates of gap W. So in this case, what is a H? We already calculated this. In this case, what is the H? So that H is 2 sigma cos theta divided by gamma into W, right? Gamma into W. Now, if you see these two expression, then it is very much clear that H plate, or you can say 2-dimensional slit, 2D slit is equal to that is H tube by 2, right? We already calculated this, right? So what is the correct answer for this question? What is the correct answer? Correct answer is half of that in a capillary tube of diameter W. So correct answer is A. A is the correct one, right? A is the correct one, right? So is it clear to everyone? Fine. Now can you calculate the capillary rise or capillary fall in case of annular space? Capillary rise or fall, capillary rise or fall in case of annular space, in two concentric tubes, in two concentric tubes, right? I think this is a case number 3. This is the case number 3. So are you guys tried this one? I think this is your homework problem. So what is the H in this case? Anyone tries this question? Anyone tried this? What is the capillary rise in this particular case? So this is the one tube, right? This is the one tube, This is the one tube. This is another tube. Right? This is the another tube. That inner tube, let us consider that inner tube diameter is small d. Right? That inner tube diameter is small d. Inner tube diameter is small d. Right? And outer tube diameter is, let us consider that is capital D. Let us consider capital D. Fine. And that inner tube is solid. Inner tube is solid. So this is the annular space. We are talking about this annular space. Now we are talking about this annular. We are talking about this annular space. We are talking about this annular space. Now this tube is in a water. Let us consider this tube is in a water. So this is the free surface of water. This is the free surface of water. And let us consider capillary rise occurs. Capillary rise occurs till this point. Right? So this is the H. This is the capillary rise, right? H is the capillary rise. Now calculate H. What is the H? So for calculation of H, again, for the calculation of H, again use the equilibrium equation. So at equilibrium we can write that weight of liquid or water, weight of liquid up to height h is equal to this weight is balanced by the vertical component of the surface tension force. Vertical component of surface tension force. Vertical component of surface tension force. Right? Vertical component of the surface tension force. And surface tension, right? If you see here, if you see from the top, right? So surface tension is acting like this, na? Surface tension is acting like this. Right? Surface tension is acting like this. Is it okay? Is it clear? Right? So we can write weight of the liquid up to height h. So weight density is gamma multiplied by the volume. And what is the volume? So that volume is pi by 4 capital D square minus small d square multiplied by h. Right? This is the volume, na? Right? This is the volume of this liquid which rises up to height h. Right? This is the volume. And this is equal to vertical component of the surface tension force. So what is the vertical component? So simply this is sigma cos theta. That's fine. Sigma cos theta multiplied by, right? Sigma cos theta, this is the surface tension, right? Multiplied with the length. Multiply with the length. So sigma cos theta pi d, plus pi times of small d. Is it correct, na? This length is clear or not? This length is clear or not? So gamma multiplied by pi by 4 into capital D square minus small d square into h is equal to, this is sigma cos theta pi and capital D plus small d. Right, now see here, pi and pi is cancel out, right, and ultimately what you are getting, that is h is equal to this is 4 sigma cos theta upon, right, a square minus b square, so a minus b, a plus b, right. So capital D plus small d is cancel out, capital D minus small d, so this is 4 sigma cos theta gamma multiplied by, that is capital D minus small d. So everyone getting this expression? Everyone getting this expression? Please let me know. Everyone getting this expression? 4 sigma cos theta upon gamma capital D minus small d. So this is the capillary rise. This is the capillary rise in the annular space, right? This is the capillary rise in this annular space. In this annular space. So I hope you can understand this. Okay. Fine. Come to the next question. Come to the next question. Next question is again MCQ problem. Next question is again MCQ problem. So read the question carefully. Read the question carefully. When the pressure on a given mass of liquid is increased from 3 megapascal to 3.5 megapascal, the density of liquid increases from 500 kg per meter cube to 501 kg per meter cube. What is the average value of bulk modulus of liquid over the given pressure range? So this is the question. Okay, so try this question. When the pressure on a given mass of liquid is increased from 3 megapascal to 3.5 megapascal. So density increases 500 kg per meter cube to 501 kg per meter cube. That average value of bulk modulus. Okay, now see. You know bulk modulus, no? Bulk modulus. Bulk modulus. Bulk modulus, that is K. And we know that it is reciprocal of the coefficient of compressibility. So simply we can write that K is equal to this is, we can write that K is equal to dP dV by V. Or in terms of density, we can write dP to relative change in density. We can write in this way. And K is equal to this is rho dP by d rho. Correct, na? So this is the mathematical expression of bulk modulus. This is the mathematical expression of bulk modulus. Okay, in question, if you see this question, it is given that pressure increased from 3 megapascal to 3.5 megapascal. So pressure increased from 3 megapascal to 3 megapascal to 3.5 megapascal. So let us consider this is the P1 and this is the P2. Pressure increase from 3 megapascal to 3.5 megapascal, and correspondingly density increases. Let us consider rho 1, that is 500 kg per meter cube, to rho 2, that is 501 kg per meter cube, right? Now I want to calculate the bulk modulus. Now beta, if you see here that k is equal to rho dp by d rho, correct na? So k multiplied by d rho by rho is equal to, that is dp, right? We can write in this way that k multiplied by d rho by rho is equal to dp. So we separate the variables. Now simply integrate. So when pressure is P1, the density is rho 1. When the pressure is P2, the density is rho 2. Because in this question, that variation is not mentioned, no? Right? Variation is not mentioned. So simply integrate it. So this is k multiplied by, now rho to the power minus 1, right? Rho to the power minus 1. So this is minus 1, and this is 1 upon rho square. Rho 1 to rho 2, and pressure P2 minus P1. Or simply we can write P. So this is P1 to P2. Correct. So this is minus K, right? Minus K rho to the power minus 2. Sorry, rho to the power minus 1. Fine. And this is 1 upon rho 2 square minus 1 upon rho 1 square is equal to, this is P2 minus P1. Right. Now put the value and get the answer. So this is K 1 by rho 2 square. And what is the rho 2? The rho 2 is 501 square minus 1 upon, what is rho 1? The rho 1 is 500 square. And this is equal to P2 3.5. This is 3.5 minus 3. Right. So calculate k from here. So what is the k that you are getting? What is the value of k? What is the value of k? Anyone? What is the value of k? What is the value of k? That answer is D. wait, just minute, just 1 minute. I'm sorry, beta, I'm sorry. Just 1 minute, na, just 1 minute. Just 1 minute, just 1 minute. I'm performing differentiation here. That is wrong, na? So this is K multiplied by ln rho. I'm sorry. K multiplied by ln rho. And this is rho 1 to rho 2. And this is equal to P2 minus P1. I'm sorry. Right? K multiplied by ln rho 1 to rho 2, P2 minus P1. So ultimately this is K multiplied by ln rho 2 by rho 1. And this is equal to P2 minus P1. Right? So K is equal to P2 minus P1 upon ln rho 2 by rho 1. Now K is equal to, so P2 3.5 minus 3 upon ln 501 to 500. Right. So I think this comes around 250, correct na? (3.5) minus 3 ln 501 250.25 megapascal. This is the value of K. Right, this is the value of K. Everyone getting this one? Everyone getting this answer? 250.25. So correct answer is D. D is the correct one. Right, D is the correct one. Okay, now come to the next question. Come to the next question. What is the work done in splitting a single droplet of diameter 4 centimeter into 64 droplets in atmosphere is K into 10 to the power minus 4 joule. The value of K is, assume the surface tension between the air water interfaces 0.073 Newton per meter. Okay, so what is the work done in splitting a single droplet of diameter 4 centimeter into 64 droplets? So tell me, what is the value of K? What is the value of K? So what is the work done which is required for splitting process? Work done required for splitting for splitting a bigger droplet into n number of smaller droplets, right? So we can write this is sigma multiplied by surface area of bigger droplet into n to the power 1 by 3 minus 1 na? Right, we already derived this one, right? We already derived this one. So sigma into surface area of bigger droplet into n to the power 1 by 3 minus 1, or we can write this is sigma multiplied by 4 pi r square into n to the power 1 by 3 minus 1, right? Now what is r? That r is, right, diameter is 4 centimeter, so r is 2 centimeter, or we can say 0.02 meter. And what is the value of n? That value of n is 64. Value of n is 64. And surface tension value is given 0.073. So this is 0.073 multiplied by 4 pi into r square. So this is 0.02 square. 0.02 square into n to the power 1 by 3. So n to the power 1 by 3 is 64 to the power 1 by 3 minus 1. And this value is equal to k multiplied by 10 to the power minus 4. This value is equal to k multiplied by 10 to the power minus 4. Now calculate value of k from here. What is the value of k that you are getting? What is the value of k that you are getting? 0.073 into 4 pi 0.02 square (64 to the power 1 by 3). So this is 4 minus 1 to the power 1 by 3. (10 to the power minus 4). So I think 11 k is approximately equal to 11. K is approximately equal to 11. Please check. Please check your answer. The k is approximately equal to 11. What is the value of k that you are getting? What is the value of k? What is the value of k? Yes, 11.002. Yes, approximately equal to 11. Approximately equal to 11. So correct answer is 11. The value of k is approximately equal to 11. Is it okay? Now come to the next question. Come to the next question. If a droplet, bubble, jet of same radius capital R of same fluid is considered in air, then the correct ascending order of the fluid bodies with respect to the pressure difference inside them and air is ascending order, na? Ascending order. Ascending order. Droplet, jet, bubble, jet, droplet, bubble, bubble, droplet, jet, droplet, bubble, jet. So beta, we already know that delta P, the pressure difference in case of liquid droplet. In case of liquid droplet, this is 2 sigma by R. Right? That pressure difference in case of the liquid droplet is 2 sigma by R. Pressure difference in case of soap bubble, right? This bubble is nothing but the soap bubble. This bubble is nothing but the soap bubble. So in case of the soap bubble, In case of the soap bubble, it is 4 sigma by r, right? In case of cylindrical jet or liquid jet, in case of liquid jet, so in case of liquid jet, it is sigma by r, right? In question, ascending order is asked, right? Ascending order, that means increasing order, increasing order. So increasing order, so delta P liquid jet, right? Delta P liquid jet, then delta P liquid droplet, liquid droplet, then delta P bubble, then delta P bubble. So first liquid jet, then liquid jet, then liquid droplet, and then soap bubble. So correct answer is B. B is the correct one. Right, correct answer is B. B is the correct one. Is it clear? Fine. Okay. Now come to the next question. Come to the next question. Next question is a MCQ problem. Try to answer this question. At room temperature, dynamic and kinematic viscosity of water are both greater than that of air, are both less than that of air, are respectively greater than and less than that of air, are respectively less than and greater than that of air. So at room temperature, room temperature, dynamic and kinematic viscosity of water. Dynamic and kinematic viscosity of water. So dynamic viscosity, we know that beta, we know that dynamic viscosity of water is greater than dynamic viscosity of air. We know that. Remember this graph, right? If you don't know the exact value of dynamic viscosity, that is not a problem, right? That is not a problem. We know this graph now. We know this graph, shear stress versus shear strain rate, right? Shear stress versus shear strain rate, right? Both are Newtonian fluid. Water, air, both are Newtonian fluid. Water, air, both are Newtonian fluid. So we know that this graph is for water, and we know that this graph is for air, right? This graph is for water and this graph is for air. We know that, right? And we also know that slope, let us consider this is the theta1 and let us consider this is the theta2. The slope represent the dynamic viscosity. In case of the Newtonian fluid, the slope represent the dynamic viscosity. So it is very simple, right? Slope of water is more as compared to slope of air. So dynamic viscosity of water as compared to the dynamic viscosity of air. That is clear. What about the kinematic viscosity? Tell me, what about the kinematic viscosity? What about the kinematic viscosity? What about the kinematic viscosity? Water, air. Tell me. I already discussed this one. Remember the graph, kinematic viscosity versus temperature graph. Kinematic viscosity versus temperature graph. We compare the kinematic viscosity of liquid and the gases, right? And if you compare the kinematic viscosity of liquid and gases, then kinematic viscosity of liquid may be more than the kinematic viscosity of the gases, or kinematic viscosity of gases maybe more than the kinematic viscosity of the liquid. But if you compare the air and water, right, if you compare air and water, if you specify the liquid is the water and the gas is the air, so if you specify liquid and the gas, then beta, then remember this one, that kinematic viscosity of air is more, as compared to kinematic viscosity of the water. Remember this or not? Right? Please go through the kinematic viscosity lecture. Right? Please go through the kinematic viscosity lecture. I already discussed all the things. Right? So what is the correct one? The kinematic viscosity of water is more as compared to the kinematic viscosity of air. That's fine. Right? But kinematic viscosity of water is less than the kinematic viscosity of the air. So at room temperature, dynamic and kinematic viscosity of water are respectively greater than and less than that of the air. Greater than and less than that of the air. So what is the correct answer? The correct answer is C. C is the correct one. Is it clear or not? This logic, this concept is clear or not? Tell me. Tell me fast. This logic, this concept is clear or not? If anyone facing a problem, whatever the concept I discussed here, if anyone facing a problem, please go through the lecture where I discuss about the kinematic viscosity. Right? So what is the correct answer? The correct answer is Chennai. C is the correct one. C is the correct one. Fine. Come to the next problem. Similar type of problem I already discussed. Come to the next problem. A steel needle of specific gravity 7.84 floats on a liquid surface. The maximum diameter of the needle is right? So there is a needle having a specific gravity 7.84 that floats on a liquid surface, right? And that liquid is water. So what is the maximum diameter of the needle? Neglect buoyancy and assume contact angle 0 degree. Take sigma surface tension of the water as 0.073 Newton per meter. Density of water is given 1000 kg per meter cube and gravitational acceleration is 9.81 meter per second square. So beta, I already discussed this problem. Remember? I discussed consequences of surface tension. Consequences of surface tension. So in consequences of surface tension, I discussed when you put needle very gently in a water, then that needle floats, right? So this is the problem. So let us consider a beaker having water. So this is the water, right? This is the water. Now in this water, needle is floating. In this water, needle is floating. So let us consider this is the, if you see from the top, if you see from the front, then this is the needle. This is the needle. This is the water. Needle is floating on a water. And if you see from the top, then needle is like this. So this diameter, let us consider D, and this length, let us consider that is L. Fine. Now, if you draw the free body diagram of needle, if you draw free body diagram of needle, so can you tell me the forces which are acting on this needle? Can you tell me forces which are acting on this needle? Can you tell me? So first is a weight, right? That first is a weight, right? Obviously weight. So weight is a W, right? Weight is acting downward. So beta, if your needle is floating on a water, so definitely this weight is balanced by some forces, right? That weight is acting downward, so definitely some forces are there which are acting upward. And since this needle is floating, so that this W is balanced by the vertical force. So what is that vertical force? That vertical force is nothing but the surface tension force, or we can say that force is nothing but the vertical component of the surface tension force. And since here theta value, the contact angle is 0 degree, right? Contact angle is 0 degree. So surface tension is acting like this. Surface tension is acting like this. Surface tension is acting like this, right? Because contact angle is theta. So surface tension is acting like this. Tell me yes or no. Tell me yes or no. Tell me. So at equilibrium condition, can we say this W is equal to, that weight is balanced by the, this weight W is balanced by the surface tension force. So what is the surface tension force? The surface tension force is sigma multiplied by L plus sigma multiplied by L. Tell me yes or no. Sigma multiplied by L plus sigma multiplied by L. Tell me yes or no. Right, so this is W, right? See, your surface tension is acting like this, na beta, acting like this. It is acting like this, right? Sigma. So sigma into L, right? Sigma into L plus sigma into L. Is it clear or not? So it is 2 sigma L and this is W, right? And W we can write density or weight density multiplied by weight density. What is the weight of the needle? So weight density of needle multiplied by volume of needle is equal to, this is 2 sigma L. Is it okay? Is it fine? Okay. So weight density, that weight density is rho multiplied by G, right? Density of needle, and needle is made of steel. So we can write in this way, right? Weight density of steel. So rho G of steel multiplied by, what is the volume? What is the volume of this needle? So pi by 4 D square into L. Pi by 4 D square multiplied by L, and this is equal to, this is 2 sigma L. This is 2 sigma L. So L and L is cancel out, and that D you can calculate. So this is 8 sigma, right? 4 to the 8. So 8 sigma divided by pi into, this is rho G of steel to the power 1 by 2, right? So you can calculate D from here. Right? So this is 8 multiplied by, what is the value of sigma? That sigma is 0.073 Newton per meter. 0.073 divided by pi multiplied by, what is the density of steel? So that specific gravity is given 7.84, right? Specific gravity of steel is given 7.84, which is equal to density of steel to density of standard fluid, or you can say water. So what is the density of steel? So that density of steel is, this is 7.84 into 10 to the power 3 kg per meter cube, right? This is the density of steel. 7.84 into 10 to the power 3 into, right? 7.84 into 10 to the power 3. 7.84 into 10 to the power 3 into 9.81. Right? 1 by 2. Now you can calculate D from here. You can calculate D from here. So what is the value of D that you are getting? So 8 multiplied by 0.073, 0.073, 8 multiplied by 0.073 pi into 7.48 into 10 to the power 3, 7.48 into 10 to the power 3 into 9.81. One by 2 to the power 1 by 2. So I think this comes 1.5916 into 10 to the power minus 3 meter. So in millimeter it is 1.5916 millimeter. So this is the maximum diameter. This is the maximum diameter of needle. This is the maximum diameter of needle. So everyone getting this answer? Please check. 1.5916 millimeter. Right? 1 point, round off to 2 decimal places. So it is 1.59. 1.59 millimeter. Please check. Everyone getting the same answer? Everyone getting the same answer? 1.59 approximately. Okay, so this question is clear or not? This question is clear or not? So again, if you have any doubt related to this question, go to the surface tension lecture. Right? If you have any doubt related to this problem, then go to the surface tension lecture. I already discussed each and every point very clearly. Okay, now come to the next problem. Come to the next problem. MCQ problem. Let C1 be the velocity of pressure wave traveling along rigid pipe carrying water with its bulk modulus 2.16 into 10 to the power 9 Newton per meter square. And let C2 be the velocity of pressure wave traveling along rigid pipe carrying oil of relative density 0.6 with its bulk modulus 1.296 into 10 to the power 9 Newton per meter square through a similar pipe. What will be the ratio of C1 and C2? What is the ratio of C1 and C2? So what is the C1? The velocity of pressure wave, right? Velocity of pressure wave, right? Traveling along rigid pipe carrying water, right? And C2 is the velocity of the pressure wave traveling along rigid pipe carrying oil. So what is the ratio of C1 to C2? What is the ratio of C1 to C2? This is the question. Okay. So better tell me what is the velocity of pressure wave? What is the mathematical expression of velocity of pressure wave? So remember acoustic velocity in a medium. acoustic velocity in a medium, right? Velocity of sound in any medium, velocity of sound in any medium is equal to velocity of pressure wave in that particular medium. So either you can say acoustic velocity in a medium, or you can say, right, velocity of pressure wave velocity in a medium, that is C, and this C is equal to root over K by rho, right? So acoustic velocity in a medium or velocity of pressure wave in a medium depends on the bulk modulus and density of a medium, right? And mathematically we can say that C is equal to root over K by rho, right? So it is simple now. C1 by C2 is equal to, we can write K1 by K2 into rho 2 by rho 1 to the power 1 by 2, right? Now C1 is the velocity of pressure wave in a water, right? So C1 by C2 is equal to, bulk modulus is given 2.16 into 10 to the power 9 divided by 2.16 into 10 to the power 9 upon 1.296 into 10 to the power 9 into rho 2. So what is the rho 2? The rho 2 is nothing but the density of oil. So specific gravity or relative density is given, that is 0.6. Relative density is given 0.6, right? Oil having relative density 0.6. So I already told you, whenever relative density is mentioned, right, and that reference fluid is not mentioned, then that relative density is nothing but the specific gravity only. So we can write that density of oil is 600 divided by density of water. So density of water is 1000. The density of water is 1000. Everyone knows density of water is 1000 to the power 1 by 2. Now if you solve this, then what you are getting, right? If you solve this, then what you are getting, C1 by C2 is equal to 1. C1 by C2 is equal to 1. If you solve this, then what you are getting, C1 by C2 is equal to 1. So correct answer is Chennai. C is the correct one. Yes, very good. So correct answer is C. C is the correct one. Is it fine? Is it okay? Okay. Now try this question. Again, this is the MCQ problem. So there is a light loaded full journal bearing. Light loaded full journal bearing has journal diameter 50 millimeter, bush bore of 50.50 millimeter, and bush length of 20 millimeter. If rotational speed of the journal is 1200 RPM and average viscosity of the liquid lubricant is 0.3 Pascal second, the power loss will be. Okay, so there is a shaft, and that shaft is in a bearing, right? There is a shaft, and that shaft is in bearing. So what is the diameter of the shaft? Journal means shaft, right? Journal means shaft, right? The part of the shaft which is inside the bearing is called journal, right? In mechanical there is a subject, that is a machine design subject, and in machine design subject, right, we discuss about the bearings. Anyways, so what is the journal basically? What is the journal? Whenever journal diameter is mentioned, that means it is a shaft diameter. And the part of the bearing, the part of the shaft which is inside the bearing is called journal, right? So there is a bearing like this, Okay, there is a bearing like this, and in the bearing there is a shaft. So this is the shaft, right? This is the shaft. Okay, like this. Fine. Now that shaft diameter is 50 millimeter, so this is 50 millimeter. This is 50 millimeter. Whereas bearing diameter is 50.50. 50.50 millimeter, and the length is 20 millimeter. This length is 20 millimeter. This length is 20 millimeter, and this shaft is rotated with an RPM of 1200. 1200. So this journal, or you can say shaft, is rotating with 1200 RPM, right? And to minimize the friction, to reduce the friction, oil is used or lubricant is used. Lubricant is used. And what is the viscosity of the lubricant? This is the lubricant, and the viscosity of the lubricant is 0.3 Pascal second. Right, viscosity of the lubricant is 0.3 Pascal second. So in this question, power loss is asked, or power required. Power loss you can say, right, or power required to rotate the shaft. Power required to rotate the shaft, you can say, or power required to overcome the friction, you can say. Power required to overcome the friction, all are same. Power required to overcome the friction, all are same, right? Power loss you can say, power required to overcome the friction you can say, power required to rotate the shaft you can say, right? All are same, and that is nothing but the P. So that P is equal to, simply we can write shear force multiplied by shear force experienced by the shaft multiplied by tangential velocity of the shaft. Tangential velocity of shaft. Okay. Can we find out the tangential velocity of the shaft? Can we find out the tangential velocity of the shaft? Tangential velocity of the shaft? Yes, definitely we can find out. Right. So what is the tangential velocity of the shaft? Omega multiplied by radius of the shaft. Or you can say omega, this is the 2 pi n by 60 into radius of the shaft. So you can easily calculate the tangential velocity. So this is 2 pi multiplied by n. N is 1200 divided by 60 multiplied by what is the radius of the shaft? The radius of the shaft is 0.05 meter. So from here you can calculate the tangential velocity of the journal or shaft, right? You can calculate the tangential velocity of the journal or shaft. Fine. Now we know the tangential velocity of the shaft. Now what is the shear force? What is the shear force experienced by the shaft? What is the shear force experienced by the shaft? So the shear force experienced by the shaft is shear stress multiplied by the shear area, right? Shear stress multiplied by shear area. And what is the shear stress? So shear stress we can calculate by using the Newton's law of viscosity, right? So from the Newton's law of viscosity, we can write tau is equal to, this is mu du by dy into, that is as. And to calculate the shear stress, we must know the velocity profile in the lubricant, right? We must know the velocity profile in a lubricant. Without knowing the velocity profile in a lubricant, it is not possible to calculate the shear stress. If calculation of shear stress is not possible, then calculation of power loss is not possible. As simple as. So in this question, velocity profile is mentioned, right? Is velocity profile is mentioned in this problem? No, velocity profile is not mentioned. And whenever velocity profile is not mentioned, then we have only one thing, that we assume the velocity profile as linear. We assume the velocity profile as linear. So we assume that velocity profile as linear velocity profile, like this, right? So this is the gap h. H is nothing but the radial clearance. H is nothing but the radial clearance. And that radial clearance is, this is 50.50 minus 50 divided by 2, right? Because 50 minus 50 minus 50, that is a diametral clearance, right? If you divide by 2, then you are getting the h. So h is nothing but the radial clearance. So this is, h is 0.50 divided by 2 millimeter, right? This is in millimeter. 0.50 divided by 2 millimeter, right? Now we know the velocity profile is linear. So simply we can write, this is delta u by delta y into as, and we can write mu into v minus 0 divided by gap, radial clearance, into as. Now put the value and calculate fs. So mu is given 0.3 Pascal second. Mu is given 0.3 Pascal second into. Now what is the v? Tell me, what is the tangential velocity of the shaft? Tell me, what is the tangential velocity of the shaft? So 2 pi into 1200 into 0.05. 2 pi into 1200 into 0.05 divided by 60. So I think this is equal to 6.283 meter per second. Please check now. 6.283 divided by 0.50 by 2. 0.50 into 2 into 10 to the power minus 3 into area. Which area? Shear area. Or you can say area of the shaft which is in contact with the lubricant. So that is nothing but the pi di into L. So we can write, this is pi multiplied by diameter of the shaft 50 millimeter. So this is 50 into 10 to the power minus 3 into length. And what is the length? That length is 20 millimeter. So 20 millimeter. So this is 20 into 10 to the power minus 3. Fine. So 10 to the power minus 3, 10 to the power minus 3, 10 to the power minus 3 is cancel out. Now calculate fs. So what is the fs that you are getting? That fs is in Newton, right? So tell me, what is the fs? That v is 3.14. No, 3.14. It is 2 pi, no? V is equal to 2 pi. This is 1200. N is 1200, no? 1200 by 60. 1200 by 60. Oh, just sorry. I'm sorry. Okay, I'm sorry, beta. Yes, correct. You are correct. It is radius na 0.05 by 2. I'm sorry. So it is v is equal to 3.14 meter per second. I'm sorry. right? 3.14 meter per second, 3.14, 3.14. This is 3.14. So what is the shear force? Tell me what is the shear force? And once you know the shear force, then you can easily calculate the power loss. So power loss is Fs multiplied by tangential velocity of the shaft. So tell me what is the shear force? What is the shear force? 0.3 into 3.14 into 2, 3.14 into 2, 0.50 into pi into 50 into 20 into 10 to the power minus 3. So this is 11.8375 Newton, and this is 11.8375 into 3.14. 3.14. So this is 37.1698 watt. 37.1698 watt. So the nearest answer is 37. The nearest answer is 37. Nearest answer is 37. Okay, fine. So I hope you can understand each and every problem. I hope you can understand each and every problem. Okay, so thank you so much guys for today's session. Thank you. Bye bye. Take care and good night everyone.